Hi, welcome everyone. So, welcome to our WIDS weekly webinar series. This is the ninth series, and I'm Julian. I'm one of the WIDS ambassadors. I work as a software engineer. I would like to just introduce you all to what WIDS is. It was initiative started at Stanford in 2015, and since then we have had the initiative become a worldwide campaign. There have been WIDS ambassadors hosting annual events in across 60 countries, 150 cities. So this is one of the largest data analytics conferences in the world. And since 2018, we have hosted this in Mumbai. But due to COVID, now we've switched to an online version of it. Our objective is very simple. We hope to inspire, educate, and support data scientists, regardless of your gender. Everybody, whoever is interested in data science, can tune into our podcast or online tutorials or blog posts and learn about how data science can help transform the world. And we mainly focus on featuring women from the field of data science, data analytics, statistics, math, machine learning, and artificial intelligence. So, coming to our local chapter of Mumbai, we had hosted our first event in 2018 at VJTI. We had 8 phenomenal speakers from across domains. We had different lectures from different segments wherever data science can be used, be it politics, be it election, math, cybersecurity. We had our second event in 2019 in DJ Sangvi College, where we had 9 speakers. Again, our audience had welcomed it amazingly, and we were thinking of a wonderful event going that was supposed to be hosted on April 4th, 2020. But now we've switched to a online series, and we've had 8 speakers so far. This is our calendar for the entire May-June month that we've had. And I would really encourage all of you who are viewing this right now to go check out our playlist. There has been an entire series of lectures ranging from linear regression right up till reinforcement learning. So please do check out our past lectures. That our speaker community has been so generous and grateful. I'm really grateful to our speaker community for taking those detailed lectures. So after 28th of June, we've had a poll in Insta and Twitter asking for what would you like next. So a lot of you asked for a code along workshop, and today we are beginning our series, but this is not exactly as a workshop would have been if we were continuing our physical meetups. But this is an attempt, definitely, to help you understand how data science coding looks like in Python. And today we're focusing on 2 things, visualization and modeling. So the first half of the talk would be taken by me, and the second half would be by my co-ambassador, Karthika, the data modeling bit. Just before we move on to our talk, I would just like to remind you all that we have had interesting content being posted in multiple platforms. So do check out our Instagram. We also have launched a podcast series in Spotify, and we regularly keep posting things on Twitter and Medium. So do follow us. And with that, let's just begin with our session today. I know it's a very hard time for all of us. Pandemic is going on worldwide, but maybe 2 years down the line, if you would like to tell stories like I do, I think a few charts would definitely come handy. And today we're focusing on data visualization with Python, but there are definitely other ways to showcase your data. You could use D3 libraries or AIM charts or high charts. There are a lot of ways products today showcase their results that are backed by AI and machine learning in form of wonderful charts, which can be connected in a pipeline to maybe a React project, how products are actually showing them. Like if you want to have a really fancy UI, you need not do it in raw Python as we are going to do today. You could connect it to a JavaScript application and then showcase it as a web application. But for the focus of today's session, I would like to just break it down into 5 very simple steps. So anybody who's new to data visualization, this is your go-to method. you need to first definitely find an authentic source. Once we've taken all the hard work and put in all of our efforts in building the charts, we don't want to be claimed as that the numbers were wrong or maybe the source was incorrect. So definitely go for an authentic source first. Second would be to focus on the objective of your charts. What story are you going to tell? Are you going to show the maximum number of recovery cases that have happened in the past few months? Or maybe you're going to show the number of infected cases. Whatever is your objective, let's first decide on that. Like anything else in life, you need to have a goal. The third would be to finding a suitable library. Now, there is definitely a way to plot things in Python by default, but there are a lot of supporting libraries that you can pick up and choose those libraries because of their inbuilt. They have so. If you've coded in Python, you know we use NumPy and SciPy for a lot of scientific and numerical calculations. Similarly, visualizations have also been provided to us by libraries. And once you have these two things in place, the data source and the library that you've chosen, all you have to do is transform your data that you have into the way that the library requires it. You might have to change some columns. You might have to make sure that you have enough things that the library requires to be for your plot to be seen. You'll get an idea once we get into the visualization types that we're going on to. So the first, these are the few charts that I chose for today. There are a gazillion amounts of charts that you can print out, but let's focus on these today. So firstly, we'll be having a line chart that we're going to try to plot it along with pandas and with matplotlib. And also, I would just like to point out one thing. Whenever you're coding in Google Colab, you have this amazing tooltip that comes up. Every time you need to hover over something, you can actually see what this library does or what does this function do. So please, if ever you want to choose between any code editing library or cloud platform, I would recommend Google Colab for a lot of reasons. This is one of them. So for the first chart, it's a line chart. We are actually using this data set, which after having read it with pandas, this is how it looks like. We have countries, the confirmed cases, recovered cases, and the deaths. These are mentioned in 3 different columns. So, and this is existing for all countries. So what you're trying to plot here is, after having read this, we can actually create a summary column. Maybe say, instead, I've removed the recovered column from here, and I've just taken cases as a sum of confirmed cases and the number of deaths. So once we have this COVID data summed up into I just want to say for every country, I want to plot how many number of cases are existing today because of COVID. So this comes down to, yeah, I'll show you the chart soon. But before that, if you also want to change the colors for each country, you can actually define that. And I would like to point out that here I've taken that data frame that I had used pandas for, and I'm going to go ahead and use the pandas data frame itself can be plotted. You can make plots of either series or data frame. And like I mentioned, you can see what each of these functions can do. So once you have used the plot function, you just have to mention what is your the data, the x-axis label, the y-axis label. And if you need any other parameters, that is also visible in this manual. You can define the size of the figure that you want, what colors to use, what title to add. So it's a very it's a complete list of things that you might have to provide for this function, and some of them are optional. So we're just going ahead and plotting it with our colors that I've been added here. And COVID is the data set that we are using. We have stored it in this. The title that we can give a title also. So this is how it looks. We have our line chart that is plotted in terms of our number of cases. They are the confirmed cases and the number of deaths. I removed the recovered cases from here. So if I had added the recovered cases, maybe these lines would have gone a little bit down. I had done it just before this, and India, because there are cases that are reducing because of that. So this is a basic chart. It looks, it's a pretty simple way to look at it instead of looking at this entire data set. So this is a wonderful way to tell a story on in a very in one glance. You would actually be able to understand what is the picture, what is the story. And of course, you're able to understand how the cases have increased from February to July in US and every other country, actually, in every country. Now, let's try to plot the same thing with matplotlib, but maybe a little different. So we're using a data set, and do not worry, I'll be sharing all of this code after this talk, and all of my data sets that I've used will also be visible and shared in our drive. So currently I'm using this in Google Colab. What I can do is I can just link my drive and make use of the data set that I've stored within this drive. So these are my few data sets that I've saved here, and I'll show you how I'd linked my drive at the very end, and that is what I'm using here. So this is another data set that I've used. It's a time series data that has the right from January all the way till I think the date is visible at the bottom. But I would like you to focus on the column names. Currently, we have daily confirmed, total recovered, total confirmed, total recovered, daily recovered. And I have, for the next plot that I'm using matplotlib to plot here, I am now planning to introduce, okay, I think I've done that for the next set. Yeah, we can actually, using these columns, what we can do is we can maybe create one more column saying daily recovered per 100 or per 1 lakh of the population, just to make it relative. In this, we have used matplotlib, as you can see. Just we've defined the figure size here again. This goes down to, we can basically make use of various functions. So every time you choose a library, please do go ahead and check out the documentations of that library, and that will give you a great idea on what are the different options that we offer. So here, this is how our chart looks like. We have, I hope this is visible enough. What I've done is I've made a background grid for this, and at 2 points I've used the axis.annotate function, which will help us actually point to specific points that we can actually see. So if you see day 47 of lockdown that I've added, this is shown here, and there's a multitude of things that you can actually do. There's just one thing that I want to show, that here was the one point where when the government had enforced lockdown, our cases actually went down. But when we try to take things a little less seriously, but it's not that the lockdown did not help. We'd had a lot of cases coming in from different places. People are traveling, students were coming back down, so our cases were definitely increasing. But there has also been a decrease because of the lockdown, definitely. And in terms, like in this data set, I just want to show you how we can point to specific things and annotate the entire chart in whatever ways we wanted to. This is one of the charts that we could plot using matplotlib. Our next is going to be district level data. So we are now zooming into India, and more focused on our districts inside Maharashtra. So this was our, okay, again, I've taken this from, I'll be sharing the data sources again, one of the Kaggle data sets that I've shared here. So in this is, so sometimes maybe line charts might not actually, so every time I have to plot here, if you can notice, I've used per column, I would have to plot line charts on each of this, right? So maybe instead of plotting line charts for each, I could stack them up in bars and show all of them together to see the entire picture together. And that's our next chart that looks like this. We have a stacked bar chart where I've shown the confirmed cases in blue, the recovered cases in green, and the unfortunate deaths in red. So this is how it goes on. For each district, we've been able to see how the number of cases have increased. And sadly, here it's Nasik that's had almost the highest that you can see. There are almost no recovered cases here. So as you can see, every data visualization is helping you come to the crucial point. In a second, you can actually look at it and say what is wrong here or what is going right here. This is going to help. Every data visualization helps you actually. When there have been news that all of us watch news channels right from the day we get up till we go sleep. So all of these numbers can actually be overwhelming, and trying to plot them in using visualizations like this helps you actually make sense of the mess around you. So this visualization is actually helping you get to that crux of the story. But if some of you might like tabular data, the next visualization I'm showing you is the data frame itself with just some colors. I've just added a background gradient here. This is a basic pandas data frame that is being plotted here. I've just added some colors in this for you to just understand the difference in the weightage of these numbers. For example, we can look at the mortality rate here in Kerala is down to 0.56, and in Goa it's 0.24. So here again, some color. So all of us human beings are very visual people. I mean, I think sight is the biggest sense that we have in terms of all of our sense, in all of our, amongst all of our six senses. So some color here definitely helps us look at that crucial point quickly enough. Now, the next thing that I wanted to introduce you is Plotly Express. This library is again used by a lot of data scientists to plot really interesting interactive data sets. I mean, data visualizations. So I had some difficulty in installing this in my local machines, but I had no issues when I had done this in Google Colab. So you can install any library that you want using pip install within this cell itself. After you have done that, when you're using this, so here, as you saw, this state level data that was being printed here as a table. If you wanted to see this in an interactive 3D chart, I've tried to plot a scatter plot here. It's a very basic function that just says scatter 3D. You have to mention what is your data frame. Just choose your, it's a 3D chart, so you have three axes: the confirmed, the recovered, the deaths, and you can give the state as your field for the different colors that you've chosen. So I would like to show you the visualization. As you can see here, this blue dot shows a total. So our data set had a total in that, and this, as you hover over every node here, you can see the confirmed cases, recovered cases for the entire nationwide data is being used here. And here we have Maharashtra with the maximum. As you can see, it's 3D, so you have the maximum of all our accesses. It's the maximum, as in you have 169.883K as the confirmed cases. Now, one good thing that I found just before this session was, in this, if you click on one thing particularly, you can actually go and see just that one dot if you want to avoid all the noise. So this is how it looks for any one particular state. Here I've chosen Kerala. Again, you're just like 24 deaths, which is also bad, but yeah. Again, here for the case of Goa, you have, okay, I'm seeing, sorry, this is Goa. This is Goa, where you have 3 deaths, and you can see, you can just focus on 2 of this. So as you can see, all of these axes get automatically rearranged based on what you've chosen. That's it from the 3D scatter plot for this. Do have fun playing around with this. I did. So I'll just move on to our next visualization. It is a bar chart. We are again using Plotly Express for this. So as I mentioned earlier, there were these 3 columns that we had: confirmed, disease, and recovered. We can, to see things in relative in a relative way, we can actually add more columns here. What I've done is just my active cases would be confirmed minus the recovered and the diseased. So I've just added a new column that says active. and for every 100 cases, how many deaths, every 100 cases, how many recovered. So I've just added more columns to the same data set. Like, this is how you can just keep modifying your available data source into the kinds that you want. And based on that, I have now defined a function that just allows me to plot based on whatever columns I need. So every time I just call this function plot daily with the column name and the color of the data and the color of these bar charts, I can plot this. So it's a basic bar chart that's being plotted. And again, if you hover over it, it shows you the entire manual that is there for this bar chart. You can just define what data frame is being used, the x-axis, the y-axis, the labels that you want. And here I've also added the color for this. So the color sequence is also given here. I've given black. So if you change it to daily confirmed or recovered cases 100, you can keep plotting different columns of the same data set. So here we have deaths per 100 cases in India. Again, this is the daily level data. So all the way from March 15th onwards till June 21st. I have taken only till June, I think. Yeah. So as you have to remember, we had our dates until the third week of June only in this data set. Definitely you can just keep on adding the moment you change your data set and rerun this cell, these charts will just be plotted for the rest of the months as well. Moving on, we have our the final form of data set that we are going to be plotting, data visualization that we're going to be plotting for today's session, and it's the global level data, the world map. Here, as you can see, I've used the Johns Hopkins University data set. It's one of the most frequently updated data set, I think. Every 2 hours or every day at least, we have an update. We have dates from all the way from the beginning till yesterday. So I just downloaded this data set before the session, and so you can see it, and it's there for every country. And you also have for per country, you might have different provinces also recording their sets. So here, after having installed Plotly, we are able to now plot this scatter plot for the entire world. As you see, this is we can zoom in and look at India. Again, India has like 6 lakh plus cases. The functions are also very simple. You have a scatter geoplot whose manual is available here. You can basically define, you can send your the latitude and the longitude of your charts. Again, it's a map, so you need to make sure your data set has these columns, just a basic pointer, and then we can actually keep changing the colors or the which column of data that you need to see. I mean, we have used July 4th here as my date that I'm using to plot, and these are also, so the only problems with some libraries is that sometimes there might be limitations, and that is why often engineers try to write invent the wheel from scratch and write their own visualization libraries, and so they have access to all of these constraints. Sometimes there are some things in this chart that you feel you might want to change. A lot of things are configurable by your parameters that you send here, but sometimes they're not. So either you deal with it, or you maybe make your own visualization library. Moving on to another form, that was a scatter world map that you had seen. The second one I want to show you is a chloroplet, where you have these colored charts. Coming to the colors, what I've done here is I've used the auto scale and reverse scale here, since it's a gradient coloring that you see here. But you can actually definitely go about defining your own set of hexacodes colors, and then use that in an argument called color scales, and then send that. It only use that. So in the interest of time, I'm not running any of these cells, rerunning any of these cells, but you can definitely go over and do that when I share this. And yeah, this is how we connect our Google Drive to this notebook that we have here. Once you run this, you can actually, it's very intuitive. You can use that. If you don't have this access here, you click on this mount drive option. This cell gets automatically printed, and once you run this cell, you would be asked to go to this URL where there'll be an authorization code, and you can just print there'll be a place where you have to enter that authorization code, and this will be mounted. So wherever I have used my data from the drive, I have just copied that data. I can just copy path here from the exact CSV, and then I just need to print that line here to get that data. So that's about it from my side. I'm definitely going to share these resources with you, and that's it. Over to Karthika for modeling.
Yeah. Hi everyone. Thank you, Julian. That was really nice. Yeah, so now we've seen the, I hope, is my screen visible?
No.
Okay, I'll just add it.
Yeah.
Now?
Yeah.
Yeah. Okay, so after the data visualization, we got some idea of how these data, the cases data is, what we can do with it, like forecasting and data modeling. So this is one way you can do. To start with, we'll be installing and importing the libraries. This Optuna library is a hyperparameter optimization library. I'll let you know when we use it. And wget is another library which is useful for connecting to web services and getting data directly from that. So why I'm using it is because one way, like Julian showed, was load your data into Google Drive and then access it into your Google Colab. But the other way is you can directly access through an API. So here I'll be using a Kaggle data set, and that I can access through a Kaggle API. Because why? The advantage is this is a time series data, and every day the data is changing. So for every day, if you want to monitor, you needn't do the entire downloading the data and uploading it, this process again and again. You can do it automatically. That is through the API. I'll talk about it when I come to that cell. So the libraries that I've used are very commonly used ones like NumPy, Pandas, SciPy, Matplotlib, Seaborn, and all of these. One thing which might be new for a few of you is FBProfit. FBProfit is a library which is generally used for time series data analysis and forecasting mainly. Here, we are not doing any forecasting using this library. We're just using this library for getting to know our data set a little more better, the trend in our data set basically. So yeah, that is about these libraries. Moving on to a little bit of theory part before we go into the code. So infectious disease like coronavirus or COVID-19, it is something which we all know now that it spreads from one person to the other in a population. And so in this kind of a situation, the questions that we can ask is how fast is this spreading, or how many people are getting recovered, is other people dying out of it? So these are the questions that come up. So to understand this in a broad sense, we can go ahead with this compartmental model. Why is it called a compartmental model? It is actually a commonly used epidemic model, and it is called so because we divide the entire population into different compartments. So like the basic compartmental model is an SIR model, which has three compartments. S is susceptible, I is infected, and R is recovered. So susceptible means on day zero of the infection, the entire population will be into the susceptible compartment. That is, everyone is prone to this contracting with this virus, and maybe only one person will be infected, and the recovered compartment on day zero can be zero. So that is the idea between these three compartments. So what compartmental model does is it divides the entire population into different compartments, and we try to understand the movement from one compartment to the other, how people are moving from susceptible compartment to infected and then to recover. So this movement is defined by few mathematical equations. We'll come to that. But before that, there are few notations which will be helpful. Capital N is total population. Like for example, in India, the total population is 13 or 14 billion. So that will be our capital N. S of t is the number of people susceptible on day t. Likewise, I of t and R of t. Beta, which is the expected amount of people an infected person infects per day. To give a little more intuition behind what this beta parameter is, let's say the probability that an infected person infects a susceptible person. So an infected person, if it comes in contact with any susceptible person, can transfer the infection, and that probability, let's say it is 25%. Then on a single day, that infected person also comes in contact with 4 susceptible people. So in net, the total will be 25%. So each person, the probability it will transfer is 25%, and it comes in contact with 4. So 25% into 4, net is 1. So in a day, it will transfer, an infected person will transfer the disease to one another susceptible person. So that value 1 is actually what is beta, then which is basically effective contact rate. Then capital D is the number of days an infected person has and can spread the disease. Like in case of coronavirus, also the person contains the disease for about a week or 2 weeks. So that duration is the capital D. And gamma is basically inverse of capital D, which is basically recovery rate. So if a person has an infection for say 7 days, that means after 7 days the person has recovered. So that so basically one person takes 7 days to recover. So in a single day, how many people can get recovered? So basic simple cross multiplication gives us 1 by D or 1 by 7 in this example. So this factor is called gamma, which is the recovery rate. And which is this is another something which you might have heard, R naught, which is the reproduction number, and that is basically total number of people an infected person can infect. So like we just saw, beta is the number of people an infected person can infect on a single day. So and but that person has a disease for say capital D number of days. So in total, beta into D, and D is actually nothing but 1 by gamma. Sorry, basically this thing. And if we substitute that, we get beta by gamma. So R naught is just, if we find out the values of beta and gamma, finding R naught value is just this beta by gamma, which is our reproduction number. So coming onto this visualization, like I told, the 3 compartments are S, I, and R. And the way the spread happens, or the movement from one compartment to other, is defined by this arrow. So from susceptible, it goes to infected. And that is defined by, so because it is going outside the compartment of susceptible and going inside I, so because it's outside, we have this negative sign. And beta is the effective contact rate. So one infected will, let's say, infect one another susceptible. So that is beta into I. But we don't really know that the person he is coming in contact to is an infected person or a recovered person or a susceptible. It can be anything. So that probability or that ratio is susceptible over total population. So from the total population, only the number of counts that people falling into susceptible compartment will be the ones which we are interested in. So that is why S by N. So all in all, the rate of change of this compartment, the people moving outside this compartment, that is given by ds by dt, is this sign with a negative, this value with a negative sign. And why? Because this value is going outside this compartment and going inside the infected compartment, we will be adding that value for the rate of change of infected compartment. And the value which will be subtracted from this compartment is the ones, the people who are going into the recovered compartment from the infected compartment. So that is minus gamma into I. Gamma is the recovery rate, which we just saw. And that is basically also getting added to the recovered compartment. So I hope you get a little bit of intuition in how this is happening. Now, it's fair, like now in this case also we can add more and more compartments. Like we can have a quarantine compartment, we can also have a death or fatal cases compartment, we can also have exposed compartment, asymptomatic patient compartment. So, and also age wise segregated compartment, like people above 60 can fall into another compartment. So we can have this, we can design our own epidemic model by adding different compartments. But the challenge is we have to also define these parameters, that from one compartment, how are people moving to the other compartment. And so just for one more example, I have added 2 more compartments, which is fairly used, that is exposed and death. Exposed is basically the incubation period. So now if you come in contact with the virus, you don't really get the symptoms on the very that second. So there is some incubation period before you get tested positive. So you're basically exposed to virus, but you're not really having that virus. So that is the exposed compartment. And so now we have to define the relation from exposed to the infected. So we have introduced this new parameter called delta, which is the length of incubation period. And now I also added the death compartment. That is why we have another parameter called rho. Like we had gamma, which is the recovery rate. Rho is now rate at which people die. So, like recovery rate, same thing. This people, the rate at which people die. So, and also from infected, there's a diversion. So we can either go into recovered or death. So if we say alpha is the probability that people go into death, then 1 minus alpha will be the probability that people will go into recover. And if we write it into the mathematical form, the same thing, it will be like this. So just to understand, if arrows are moving out, the sign is negative, and if it's moving in, the sign is positive. Okay, so how do we code this? This function does nothing. It's just a very plotting. We're just using this function to plot everything, all the different compartments, the values in all the different compartments. This function is where whatever we just saw here, we'll be just writing it in terms of code, like as it is, nothing much. So there's this function deriv, which is having all these parameters in the arguments, and the same actually these things these equations are called ordinary differential equations, ODE. So we'll be just writing that. And now in this cell I have based on, just for example, based on, I mean, just for example, I've taken few values just to show that how the plot looks like. So let's say capital N, which is the total population, is around 10 lakhs, and the incubation and the sorry, the infection lasts for 4 days. So D is 4. So likewise, the other parameters also, I've just given few values, almost random values. And the initial condition is also something which you have to define. That is, on day 0, what is the situation? So on for the number of people into susceptible, that is S0, initial day, will be the entire population minus 1. And that one person is actually exposed, which is the one that is the person who will be, doing the entire community transfer and all of that. So as time passes. So this is the initial condition. We'll also have to define our time period, which is which will be using this linspace for that. And then after defining all these parameters, we'll be using, this is a very useful thing. Like I told, I use a SciPy library, and we'll be using this ODE int function. And what this does is it helps in solving these ordinary differential equations. So all we have to do is give in the arguments all these parameters that we define, and the deriv, which is the function which is having all these ordinary differential equations described. So if we give it in the parameter, it will do all the computation on its own. We don't have to worry. So that's as simple as this. And it will return the values for all these compartments. And at the end, the plot function that we had described, we can just use it and plot. And this is the example. So these values are just, dummy values. So when we see flattening the curve and all of that, this is the curve that we talk about. And on day 0, entire population is susceptible. And as time proceeds, this goes down. And people who recover, which is the green line, increases. So this is the idea about these compartmental models. Coming into now the next part, I won't spend much time. I'm just going to go a little quicker in this part. But here I'll be using the India specific data. So for that, like I told, I use a Kaggle data set. This person, which is this data, I hope you can see this tab also. So I'm using this data set because this person again uses data from the Johns Hopkins website itself, but it's a little more structured and easy to use. And I'll tell you how to load your data from Kaggle directly onto the Colab. So when you have your account created into this Kaggle, you can go here, my account, and over here, this place, we can, when you click on create new API token, a kaggle.json file will get downloaded, which will have your name and token. So that you'll have to copy paste over here. So username is that name, and key, I have erased my key in for now, but you'll find your key and you can add it over here where I put this dashes. And then after running these few cells, your, and also one another thing is to fetch that API, to get that API for this particular data set which I've used. When you click here, the three dots, you get this copy API command, and that you can use it, which is basically this command. This is what it is. And you can copy paste, and then your data will get downloaded. You can unzip it. So the data that the CSV file I'm interested in is this one. So if you see the tail of it, this is what it is. It has different countries, its provinces, and the number of cases for confirmed death and recovered as the days till date, like till the 30th of June. Now we are interested only the India data, so we don't want other country data. So we'll just remove and play. I mean, just create that format that we want. So that is what I'm doing over here. When I see the India data, I also realize that for the June month, what they have done, what they've done is for every day they have multiple entries. The multiple entries correspond to different states. So they've segregated the data as per different states. But before June, they had only one entry for one date. That is the total India cases. So now this is the difference. So how do I use it? So I'll have to, because I'm interested in only the India data. After June, I'll have to group by date and condense all these different states into one particular row. So that is what I did. I used a group by, and so finally we have our data set, which looks something like this, which this is the India data set, has date, infected, death, and recovered columns. Now, there are sort of few functions that I've defined and few classes which will be useful to do the entire thing. We'll push this code into our GitHub. I'll share the link of this code in the description of this YouTube video or after post this talk, so you can go and access. But I'll just give you an overview of the entire thing. So the show trend, like I mentioned in the beginning, FB Profit, that library is used over here in order to understand the trend of the data, the current data. And why is it important is because I'll mention one other thing. So like in the, like when I started with, I didn't tell you that these values, that beta, gamma values, what are these values? So if we have to do this whole modeling for India, we need to, it's very crucial for us to know these parameters, but we don't really know these values exactly. So what we'll be doing is, from the existing data, we'll try to curve fit and find these values on our own. So that is basically hyperparameter optimization. Uh, uh, we have few set of equations that we saw, that ordinary differential equation. We'll have to fit the current data into those equations and get these parameter values, the best values that fit this curve. So that is why we are using the hyperparameter optimization library called Optuna. We can also go with other options, like we can fix one parameter, say we can define some range, and then for the other parameter, we can do a grid search. So there are different ways that we can do, but here is one way. So now coming back to the point where I stopped, show trend. So we are just seeing trend. So for the infected cases, this is a trend. So this dotted red line shows the change point. So till say March, there was one particular trend, and then the trend changed. So now the latest trend which is followed is after May. So this is the way, and this is a log scale. That is why you don't really see that exponential or thing. This is a little, this is log scale. And same way for recovered, and as well as this depth. So we can take the common of all these three intersection. We can take May as a start date because so now for optimizing or finding the parameters, we'll have to if we say our start date is February or March, that time our data was not even evolved. So if we rely on that data and find these parameters, like when I say parameters, I mean the recovery rate, the contact rate, and all these rates, reproduction number. So if we rely on the initial data, our data was not yet evolved, so we can't really get those exact values. So, and to find the latest kind of parameters, we'll have to depend on the latest trend. So that is why we'll consider the data from March to find these parameters. So that is about trend. And then set of functions like, again, a plotting function, basic plotting function. And this is just to create the target data set that is basically susceptible. That compartment is total population minus people who are infected, recovered, and dead. So we're just creating that data set here. And like you saw that ODE in, which is a SciPy function for solving ordinary differential equations. Here, a similar function, again by SciPy, called solve IVP. It does the same thing, but it has a little more better functionality, and it's a newer function. So that is used to solve the same thing. And this is where the challenging thing is, the estimator class that I've defined. So like I told, that hyperparameter optimization, we need to come up with those parameters. So here we'll be estimating that. And there are multiple functions in this, and every function does one particular task, which is like a good coding standard. And I've also written a doc string. So when we push the code, you can go and check it out for yourself. But the only thing I'll highlight here is Optuna, which is a library, that hyperparameter optimization library that we had used. It creates a study and it tries to minimize the objective function, which is also defined over here. And it also plots the graph for us to understand how the data, or what are the parameters, and is it close to the observed values, the estimated values, are they close to the observed values. So that is about the estimator class. And then here I've also defined a base class. This is having, I mean, the basic, the required functions, and we'll inherit this class in order to create our own model. So here, for example, I'm displaying the SIRD model. You can also have your SIR model, or you can add many different compartments and just inherit this base class and change the differential equations as per this. So for SIRD, this is what it is followed. And yeah, so that is about this. And predictor, what this does is predicts the future data depending on the parameters that we found from this existing data. So it is just basically forecasting for in the future. So, and it also plots the graph. Coming on to how to use these functions. So like I told you, estimator, first of all, we'll have to begin with estimating these hyperparameter values. So estimator will take in the model, which is the SIRD model here. And India is basically the data set name, that CSV file name, just to avoid confusion. I'll show you. So here I had defined that I've given the variable name as India. So that is what that CSV file. That is what we are giving, the data frame, basically, sorry. Yeah, so here, India, and population is this, India population, and we are doing it for India country, that's just the name. And start date, like I showed, that show trend, it was giving the different trends, the changeover points. So we took May 1st as the start date, so that we have to define over here. So after that, and if we run our experiment in order to find those parameters, that is there was a function called dot run in that class. So after doing that, and also the graph, if we plot that, we get this. I'll explain this. So what it is doing is, here Y is infected. Yeah, Y is infected, R is recovered, and sorry, Y is infected, Z is recovered, and W is defined as death. So for all these three things, um, the orange is the estimated values and blue is the observed values. So estimated values are based on the parameters that that the function has returned, and blue, the observed value, is what the existing data is, the case data is. So if we see, there is almost the estimation is also following the same kind of curve. So we can safely go ahead. It's like reassurance. So we can safely go ahead with the parameters that the model has predicted. And what they, if you just print those values, that parameters that the model has predicted, these are the ones. So R naught, which we generally hear, that is reproduction number that it has, this model has given, or this function has given, is 1.69. And likewise the other, so there will be a little difference, like beta, gamma, the function, the values that I initially defined, here it can be a little different. Sigma, rho, these are different values, but it's just the naming is different, but otherwise it's the same thing. Then yeah, and finally we'll have to use a prediction predictor class. We'll be using that, and we'll do the prediction. And for predicting for the future 300 data points, I have done that, and this is what the curve looks like. Now we don't really understand what it is. Like this, if I try to interpret this, it tells that somewhere in Jan is what the peak will arise in the infected number of cases. So it's like, can we trust this output? We cannot really, because it's based on a lot of assumptions, and I've used only limited compartments. And another thing is, I've done it for India as a whole, and we now know that India is such a diverse country, and every state has its own different dynamics. Like Mumbai has its own different dynamics, so we cannot account it as a whole like in India. So we'll have to go for localized model. And this is an article which recently came up in Ken, which I found really useful and relevant. So I'm sharing a little screenshot of that. So after global models, national lockdowns, India finally has local COVID models. Uh, and like I told, early mathematical models from COVID-19 for COVID-19 came with an expiry date. Now, post-lockdown, preparation is best left to localized models that account for cities' unique characteristics. So to give an example of, it comes with an expiry date. When I did this whole coding thing, coding the compartmental models, I did it for the first time in March, early March, with the limited data that we had. And this is what my model had predicted. In fact, you might have also seen few people predicting that June, July is when the peak is going to arise, and we are already in June and July, and we are not seeing that peak yet. So that has already expired. So we have to do, I mean, with every passing day, you have to account more and more information. So this is basically a work which needs to be done in close collaboration with the government with the current up-to-date data. So that is the challenge. And there are few more things, like mathematical models are useful. They help in planning for medical facilities, and in the case of COVID-19, guidance for lockdown implementation. So now, like, you might also have this question that if this model is not giving the result, which is, exact result or something, why are we using this? The reason is, a number of early models predicted case numbers much worse than what we see today, but they are useful predicting the disease wasn't going away anytime soon. It just gives you a rough idea that this is a crucial thing and this is going to happen. So please, do something. So it's just going to give you that kind of a warning. And now the need is for localized models, which can give specific recommendations attuned to specific cities. A number of models are in the works, but without access to data and an active collaboration with government task force, their utility is limited. Uh, Here we talked about only compartmental models, but because I'm giving you an overall idea of what is happening currently, I'll just introduce another model called agent-based model, which is also something which is like, these two models are commonly used here in India. The difference is this. Again, I've taken this chart from the Ken article itself, and for the agent-based model is very complex. So basically, it's sort of like a reinforcement learning, wherein you simulate your entire city and every person is an agent in that city and how this person is moving. So that is all simulated. So it also accounts for a lot and lot of assumptions. So that is computationally very expensive also. But that will not really give you the cases, the number of cases and all of that. What this agent-based model does and is useful for is to understand what policy is going to work how. So for example, should we introduce the lockdown or should we remove the lockdown or what needs to be done? So all these should be, like for in Mumbai, should we allow the local trains to function or something like that. So that is the idea behind agent-based model. And yeah, so finally, thanks to all these blogs and kernels, because I also had no background in epidemics and all of this. I have also read all these blogs and kernels, and a lot of things are just taken from here and there, and I've done this. So I hope this was useful. We are open to questions now. Yeah, I think we don't really have any question. Yeah, the code and everything will put it on our Vids Mumbai GitHub page. We have not added it yet. We'll do it after this call, and in the YouTube video description, we'll add the link so you can check it out after a while.
I guess no questions. But thank you so much for joining us, and do look forward to our next session, which will be on July 11th, and we'll be having a similar session by Karthika. So do stay tuned to our Twitter and Instagram channels where we post regular updates. And thank you so much for joining us. Yeah.
Thank you.
Stay safe.